The question talks about a car that stops suddenly, and you feel like you're basically thrown forward. And the question wants us to basically model this sort of situation. So, in this context, there are a few things that we want to do that relates to what we learned in class. For example, we want to use force diagrams to show what forces are being acted on you and basically which way you're accelerating based on those forces. We also want to think about the idea of inertia, or how something in motion or not in motion will not change its speed unless acted on by another force. Another thing we want to think about here is friction. This very, very strange sort of force that either slows you down while you're moving. I mean, it could not, it doesn't necessarily slow you down, but it will push against you while you're moving, or it'll try to keep you still. And this is a force that we probably haven't done too much of until now. And another idea here is how acceleration and force relate, how if there's a net acceleration, there is also likely a net force. So, to solve this problem, we really, really need to pay attention to the acceleration. So for part A, we want to draw a picture and identify all the forces that act on you as the car travels a steady speed. So here the car is traveling a steady speed. I have this very artistic picture of a car, and basically there's no net force. And in this sort of situation, the bench is really, really slippery in the car that you're in. So that basically means there's no friction on the bench. And this time the car is decelerating here or slowing down. And in this situation, the car is slowing down, but you aren't. So you basically you keep inertia and keep moving while the car is slowing down. So that's why you feel like like fly forward, even though you're not. So the next part asks, describe what happens to you as the car slows down. You basically fly out of your seat and will likely hit the seat in front of you because there's no friction holding you in place. And use Newton's laws to explain why being thrown forward, you feel like you're being thrown forward even though there's no force pushing you forward. Well, this is because the car is slowing down, but you're not. So and it's like everything's slowing down around you while you're not slowing down. And that is the idea of inertia and how you keep on moving unless acted on by another force. You're not actually accelerating, only the car is has a negative acceleration, which in context of the situation makes it feel like you are flying forward because the car is slowing down. And now we want to think about what happens if the bench is not slippery. In this case, friction would essentially keep you from not flying forward by exerting a force on you so that you accelerate as the car accelerates. And I show this in this free body diagram here. And this specific force is static friction, which is a really interesting example of static friction because this is one of the few examples which static friction actually causes an acceleration to occur. And this is just a really interesting example because static friction is basically the net force in the x direction here. And it's specifically in a way so that you will decelerate with the car. Finally, a common mistake someone can make with this problem is that they assume that the person accelerates if the car stops, even when not accounting for friction. Um, because if you just think about it without understanding Newton's laws, it feels really strange that you kind of feel like you're being flown forward even though you aren't. So this is just a really common mistake people make. Thank you.